Good morning. Okay, so we've got something to think about over here. Whilst I just finish setting up, guys, and if you need to go and grab some bits to join in, you can do as well. Please do feel free to like and subscribe. It does help people knowing where we are and what we're doing. I'm not going to be much longer. I'm going to be like a couple of minutes max. Have we got bits to make a sandwich? I think we have. Oh, it's so hot outside today. Hot, hot, hot already. Okay, where are we at? Okay, good morning, Matsmo. How are you doing this morning? Do you like these? Do you like this? These are new, and they're handmade by someone, and I just thought they were super cool. They're meant to be for a wedding I'm going to, because I've got like a whole sunflower thing going on. But you know, some days you just need cheerful earrings. And today is one of those days. How are we doing today? My name is Ruth. I forget to start with that. This is Joyful Maths with Ruth, and this is my Functional Skills GCSE math lesson, where we're looking at working through all the stuff on Functional Skills 1. We'll cover all the stuff in Functional Skills 1 and Functional Skills 2 in the course of just over a year, and then we'll go on to mop up all the stuff that has not been covered in those that we need for foundation GCSE. I'm focusing on Edexcel, all the content, huge crossover. You'll find everything that's in Functional Skills 1 and Functional Skills 2 also in GCSE. Our GCSE edits are slightly different because of the calculator, because you can use a calculator for everything. My job is to deliver the content for you. I'll make sure the content's there. I've been teaching maths for 15 years. I was a head of maths. I know all the content inside out. Your job is to know which qualification you're working towards and do the right bits for you. So I'll make sure you know that. We started off with a question. And this was interesting. I found this fascinating on Tuesday when I did this on Facebook to see the number of answers that people got. I'm wondering what you guys got. We've got quite a range of answers. Let me think now. So I think a lot of people got 5. Did anyone get 5? A lot of people got 5. And then the other answer that was really common was 120. And some people put things like 110. I think they were the most common answers. Did you get any of those? Should we have a little look? Funnily enough, if you put this in your calculator, it will consistently give you exactly one answer. If you've got a calculator to hand, try putting it in and see if it gives you the answer you put down, whilst I just have a little sip of coffee. What answer did you get when you put it into your calculator? I've left my calculator somewhere. That was silly of me. Fortunately, I know how to work this one out because I plan this, so I can plan questions. I know how to work out, hey? So your calculator will always do it in a very specific way. And I can see how people got both of these, well, all of these answers. Because if you're working like we do in English, going from, let me just check my left and right, from left to right. If you're going from left to right, it makes sense to go in order and do 230, take away the 220 and then divide that answer by 2. So if you do that, 230 take away 220, that gives us 10. There's just a difference of 10 there. If I divide that by 2, I end up getting 5. But that's not the answer you'll get on your calculator. And I'm wondering if you know why that is. Why might it be that your calculator does not give you 5 as your answer? In fact, I think your calculator should give you 120. I need to just double check that. 120, I think. 120 on your calculator. Should we have a little look? So it is because your calculator will know about the order the operations have to go in. So your calculator knows that there are some operations that are more important than others. Just like in English, we would write from left to right. In other languages, you don't always write from left to right, and I'll go into that in a second. Maths is another type of language, and we need to know what order things go in. And maths doesn't work necessarily going from left to right. Sometimes it is important to go from left to right, and we'll talk about that in a second as well, but not every single time. So actually, in this case, where we've got 230, take away 220, and then divide by 2, the divide is more important than the subtract. When we're talking mathematically, we would always do a divide before we do a subtraction. So we'd actually do the 220 divided by the 2 first. So when I do this, I get 110. Now, this is where left to right is important, because for a subtract, we do have to work from left to right. So it's important we start with the 230 and then we take away the 110. For subtract and division, it has to go in that order. And that's how we end up with 120. I think the people that got 110 as their answer just made a silly mistake with their subtraction there. So that's how we end up with 110. However, we could alter this. We could alter this calculation to make it make 5. How could we? Any ideas? You might want to have a little play with your calculator. How could I alter that calculation to make it so it does equal 5, keeping all the same numbers, written in the same order? If I wanted to get the answer 5, how could I make so I am getting the answer 5? Have a little think about that. I'll do my expert being quiet for 5 seconds. Any thoughts? It's an odd one on this one, like on here, because I say, have you got any thoughts? And then I don't get your answer. I have to just guess. Which is why I do the Facebook one first, actually, so that I've got some ideas of what people say. So what we need to do, and this is what people pointed out to me on Facebook, we need to make the subtraction happen first. And some people knew this already and some people didn't. So if you don't, I'm telling you now, we can do that by popping brackets around that subtraction. If we pop brackets around that subtraction, our calculator goes, whoa, brackets, whoa, they are like not to be messed with. We better sort those out first. And they do the calculation inside the brackets before they do anything else. So they're going to do this subtraction first. I'm talking about a calculator like it's a living, breathing being. But also humans need to know this, because we also need to know the order in which to do the calculation. So we're going to do this 230 take away 220 first in this case, which gives us the 10. And then we divide by 2. Again, with division, it's important to go from left to right. If we did 2 divided by 10, it's a totally different answer. So we end up getting 5 in that case. So we can make that happen. Okay, we're going to start a little activity here. I don't know if this helps you understand order of operations, but in my head, this makes sense. I've said, let's make a sandwich. So I asked you to bring along 2 slices of bread. Now, I've had exactly the same issue come up today as I did on Tuesday. You would think I'd have checked this in advance, wouldn't you, and learnt my lesson, but apparently not. So we make bread in a bread machine, which means I actually have to do that in advance of needing the bread. That bit hasn't happened, but I found some wrap. So I've got 2, these are slices of bread. Believe me, they are. Yeah. So 2 slices of bread. I said a plate, something to put inside your sandwich that is in a container. So I've got peanut butter in a jar. Okay, but you choose what you want. And some sort of knife to set it with, or put it on with, slap it on with, or something like that. I don't know. I was trying to guess what you've got as you're filling your sandwich. Okay, I'm going to tell you what to do. I'm just going to tell you what to do, and we're gonna make and eat a sandwich. Okay, are you ready? You ready? First step then. First step. You ready? So the first step is eat the sandwich. You all eating your sandwich? How's that going for you? No, we can't. We can't eat the sandwich, Ruth. We have not made a sandwich yet. I would just be eating different components. I would be spooning peanut. I mean, it's happened. It's how I won't pretend I've never done that before. But I would just be. I'm not doing that live on camera. I would just be spooning. That's a new word, isn't it? Spooning peanut butter to myself and eating. That's not a sandwich. So scrap that. We're not going to just eat the sandwich. We actually have to think about this. So, actual first instruction. Let's put one slice of bread on our plate. Okay? One slice of bread on our plates. And then spread the peanut butter or whatever you've got, whatever you're using. Let's spread it on there, yeah? Should we get it spread on? No, I'm not. I haven't opened it. Obviously, it's going to be really hard to spread like that, isn't it? If I just start trying to, yeah, it's not going to be the delicious peanut butter sandwich that I was hoping for if I just shove on the whole jar of peanut butter all in one go. So let's think that we need to think about that again. I obviously need another instruction first. I need to open the lid. So you can open up whatever you've brought, and now we'll spread the peanut butter or whatever you are using to build your tasty sandwich. We can spread it on. Now, it's not the easiest thing to spread peanut butter, is it? But you get the idea. Or if I did think my kids like a ham sandwich that maybe you wouldn't spread that on, you would just sort of slap it on. You wouldn't necessarily need the knife. Maybe you cut it up a little bit. I don't eat meat, so I wouldn't have a problem. But maybe with cheese, I would have that issue. I would have that issue with cheese. Okay. So now I've got my peanut butter on my sandwich. Eat the sandwich. Eat this. Well, I could. It tastes all right, but it's not what I would call a sandwich. Right now, it's sort of maybe an open sandwich. I'm eating something, but I don't think it's a sandwich. I think I actually still need to do something else. So let's change that final instruction to put in the last piece of bread on top. Pop it on top. You might need to do a bit of squidging if you've got peanut butter like me. And then, finally, we've made a sandwich. We've made a sandwich, and now we can eat the sandwich. Now we can eat the sandwich. And, snacks are important, so eat the sandwich. That's actually my breakfast. What am I getting at here? What am I getting at here? Probably that I'm hungry. But also the order we do things in is important. And that's the same in maths. And I talked a little bit about how English goes from left to right. I actually looked up some other languages. I don't know if that's going to be confusing showing you that. But English, when we're writing, we start at the top in the left-hand corner and we go from the left to the right, but we also travel down the page. So we write like this. Other languages don't all do that. So Persian, the Persian language, they go right to left and travel down the page. So it's right to left, but also traveling down the page. But apparently Mongolian, totally different. They start at the same place as us and they go down first and go down the page and then travel from left to right. So you can see it's all in different directions. And maths has its own language, but it doesn't involve directions. It doesn't involve going left to right, right to left. Like I said, there are some calculations such as subtraction and division. It's important that you do go from left to right. But we've got like a super, how can I put it, an order. Some operations are just more important or higher ranked than others. So I've got this to just sort of demonstrate this. Like, what order does maths go in? What do you notice about these 4 calculations here? What do you notice about those 4? Have a little think, and I'll tell you some of the things that people on Facebook said. Can you hear me eating a sandwich in the background? Do they all look the same? They're not the same, are they? Because we've got all the same digits. So we've got a 7 in every single one of them. We've got a 4 in every single one of them, and we're adding the 7 and the 4 together every single time. And we've got 11 on the other side of the equal sign each time. So they're all representing pretty much the same thing, aren't they? That when we add 7 things and 4 things together, we get 11 things. But they're all written differently in different orders. So what's important in maths is the order that we do the operation. So it's not about the fact that it's an add. It's not about the fact that it comes in a particular place in the equation or the formula. It's about the fact that it is an add and where that comes in relation to other operations. So we saw from that starting question that brackets is the most important. That's like, do not pass until you have sorted me out. You absolutely will not mess with a bracket. And division needed to be done before subtraction. So far we've got brackets is like our queen of operations. It is the absolute top dog. Division is in the middle, and then we've got subtraction at the bottom here. You just have to wait your turn. Subtraction, I'm afraid. Wait your turn, subtraction. Okay, what about multiplication? Let's have a look at these two. Have a little think about these 2 calculations. What answer do you think you're going to get for these 2 calculations? You might notice something about them. What answer are you going to get for these 2 calculations here? You can try putting them into a calculator as well if you want. I'm not even going to try and be subtle about eating the sandwich. So lots of people on Facebook noticed that it gave exactly the same answer for both of these calculations. Both of these calculations give 23. They're exactly the same calculation written differently. And that is because your calculator will do the multiply before it does the add. It will do 4 times 5, which gives you 20. And then it will add on the 3, which gives us 23. So in this first calculation here, it didn't matter what order it went in. It mattered that that was a multiply. The second one, we actually do end up just going left to right. 4 times 5 gives us 20. And then we add on the 3, which also gives us 23. So multiplication comes before adding. It's more important than addition. What about, I've got another one here. Let me turn you around again. Let me turn you around. I feel like I'm on a bit of a go slow today. Like my body's just not reacting to things. I don't know if that's my brain or my body. Can't tell. Can't tell. Let's have a look. So we've got these 2 here. Again, feel free to use a card. Oh man, I didn't. I did this on Facebook and then forgot to change it. I was meant to get you to do these calculations to see what happened. I think I deleted the slide. Right. Let's pretend you didn't read that. Why do these 2 give us different answers? So if you look before, this is what I gave you before. They both gave 23. Why do these 2 now give you different answers? Why are they not giving the same answer as each other? Pretend you didn't see what I've written on the slide. No, don't. I'm joking. I'm totally joking here. So here, the brackets are more important than the multiply. Oh, I've not even spelled important properly. Gosh, Ruth, that was a rubbish slide. What were you doing? The brackets are more important than the multiply. So it's changed what's happening here. It's changed the calculation fundamentally. So with 3 plus 4 times by 5, we saw that we were doing the multiply first, but then brackets came in and they went, whoa, out of the way, multiply, I'm more important than you. And so we had to work out what was inside the brackets first. 3 plus 4 gives us 7. We multiply that by 5 and we get 35. So in that case, in that calculation, the brackets actually changed the order of the operations. In the second calculation, we had 4 times by 5 plus 3. We saw that initially we did the 4 times 5, but then I popped some brackets in, and the brackets again changed that order and said, no, you've got to do what's inside this before you can do that multiply. We are more important. I am the queen of operations. Out of my way. I absolutely want to be done first. So 5 plus 3 gives us 8, and then we're doing 4 times by 8, which ends up giving us 32. So without the brackets, they gave the same answer. With the brackets, it totally changes. So brackets remain our queen of operations, the absolutely most important one. Multiplication and division. These ones are inverse of each other. They can be done at the same time as each other because one is the inverse of the other. Addition and subtraction, again, one is the inverse of the other. So they can be done at the same time as each other. But we need to do brackets before we do multiplication and division, and we need to do multiplication and division before addition and subtraction. Okay, let's have a go at some. So let's try some. What I'm going to do is I'm going to go through, how many questions have I got? Let me remind myself. I'll try and remember. Oh, it's not going to, is it going to let me see? It's not going to let me see without taking it off the screen. Okay, I think I've got 4 or 5 of these. So we'll have a go at these, and I'll go through each of the answers for you. So you have a go first without a calculator. Unless you're doing GCSE, you will need to be able to do these without a calculator. So I've got 10 plus 2 multiplied by 2. Okay, let's have a little look. So 10 plus 2 multiplied by 2. Multiplication is more important than addition. So I'm going to do the 2 times 2 first, which gives us 4. And then I do the add. So 10 plus 4, which gives us 14. So that calculation gave us 14. Next one. Oh, man, my PowerPoint's not doing its thing. There we go. 100 take away 40 times 2. I've popped the order of operations for you just up here. How are we doing? Are we ready for that one? Okay, let's have a look at this one. So with this one, again, the multiplication, more important than subtraction. So we're going to do the 40 times 2, which gives us 80. And then it's 100 take away 80. And again, this bit, it is important to go from left to right. So we end up with 20 in that one. What is going on with my PowerPoint? It's just not changing for me. Technology. Right, I know that's the same question. I know that's the same question. Give me a sec. I'm going to get this working. I don't know if I can. There we go. 60 divided by open brackets 1 plus 5 close brackets. So you've got the order of operations. If you need a reminder, just down the side here as well. How are we doing with that? It includes a little bit more, that one, doesn't it? Includes a little bit more. We've got division, we've got brackets, we've got add. Don't bypass the brackets. I don't want anyone getting beaten up by brackets. So we need to do the brackets first. 1 plus 5 gives us 6. Then we're going to have to do the divide. So 60 divided by 6. We're going left to right because otherwise we're going to get a totally different answer, which gives us 10 in this case. Okay, I've got 2 more of these. So next one, 21. Take away 9 divided by 3. What do we recommend that one? What would you do first? Would you do the divide first? That's what I would do first. So I would do 9 divided by 3, which actually happens to give us 3, which is nice. Nice square number there, 9. And then 21, subtract the 3, which is going to give us 18. And the final, that was the final one. I thought I had another one. Okay, I was lying. Not intentionally. Right, quick recap then. 7 squared. I'm going to turn this around so you can see what I mean by 7 squared when it's written down. Do we recall what 7 squared is or how we would work it out? I'm not asking you to memorize it, but we do need to be able to work it out. So you do need to know this bit for functional skills 1, but then you don't actually need to use it in the order of operations, which I find a bit bizarre. But anyway, that's what it says. So we'll stick with what it says. 7 squared. Do you remember that? It might help to actually think of a square. It helps me. It helps me to think of an actual square. So 7 squared is what happens if you've got a square that is 7 by 7. So if we've got a square like this, there's 7 across and 7 down. When we want to find the area of that square, like this, we would do 7 times 7, and that gives us 7 squared. 7 squared is written with a little 2 above here. That's called an indice, which is what we're going to look at now. So 7 squared gives us 49 because we 7 times 7, which gives us 49. Another type of indice is this, which we've not talked about before, but you might have seen. Have you seen this symbol? So this symbol here, can you see this? It looks like a tick, but it's been elongated. So that means square root. It's also an indice because we can write it with a little number, which we're not going to go into today. But this here, this little tick is called a square root. And the square root of 49 means what numbers did you multiply together to get 49? And those numbers had to be the same as each other. So it's the inverse of squaring. So if we want the square root of 49, we're going back to this square and we're saying what was the length and the width. And in this case, it was 7. Cubes and cube roots, they are also indices. So although you need to be aware of and be able to calculate square and square roots in functional skills 1, you don't need to be able to use them in order of operations. So it's not a massive difference once you've done the rest of it to add this in. So I'll leave it up to you what you do with this. Functional skills 2, GCSE, GCSE, you absolutely do need to know this bit. Okay, so let's have a look at this one and how it changes it. We've got 2 plus 5 all squared. 2 plus 5 all squared. This is the calculation we're going to do. Have a little think, and then I'll talk about how I would go about doing this. You have a think about what you think the answer to that might be, or what you would need to do first. What would you need to do first? You're probably thinking, a bit scared of those brackets. I'm not going to be messing around with those. Too right. We absolutely don't mess around with the brackets. The brackets are still going to come first, but the brackets are telling us what we're squaring. So we're going to do 2 plus 5, which gives us 7, and that is what we're going to square. And we know already 7 squared is 7 times 7, which is 49, because I've just told you that bit. Okay, so 7 squared is 49. We have to do the brackets first. If the brackets are not there, that would change it. If the brackets weren't there, we would do, in this case, we would do 5 squared before we do the add. So we would do 5 squared, not the 2 because it's not in the bracket. So we would have to do the indices first, 5 squared, which gives us 25. And then we would do 2 plus the 25. And that gives us 27 like this. So if I had something like this calculation, I'll show you. Don't panic. You're not supposed to read it off my face. I've actually got it on a PowerPoint. Here we go. if I had 50, take away 2 squared times 4, what calculation? Well, what would you do there? What would you do first? You are probably thinking, well, maybe. This I'm going off of what people said from Facebook. We're going to do that squared first. And you're absolutely right. So we would do the 2 squared first. 2 squared is 2 times 2. That gives us 4. We are going to then multiply that by 4 because multiplication comes before subtraction. So now I'm going to need to do 4 times 4, which happens to give us another square number. So 4 times 4 gives us 16. And then I'm going to do the 50, take away the 16, which ends up giving us 34. So indices comes into our ranking of our order of operations below brackets, because brackets are boss, but above everything else. So if you've got something like a square root, a cube, or a cube root, you're going to do it after brackets if you've got some brackets, but before any multiplication, division, addition, or subtraction. Lots of people will call this BIDMAS. Some people call this BODMAS. And I've discovered I've got issue with that. But some people call this BIDMAS because you've got brackets, the B from brackets, I from indices, or the division should come first. So D from division, M from multiplication, A and then S from subtraction. So it gives you that order of operations, something to remember. Okay, so we're going to end this on a little quiz. Now, I've noticed, I think I've overcomplicated some of my quizzes and made them hard to join in on. So I'm going to explain this one first. I'm going to give you an example and then you can join in with the rest of them. So same or different, this one's called. So I'm going to give you 2 calculations. They're going to look very similar, but there's going to be a difference in them. And when you do the calculation, I'm interested in the answers to them. Are the 2 answers the same or are they different? Okay, so I'll show you this one. I'll show you the first question and then I'll tell you what I would do here. So we've got 4 multiplied by 7 take away 1. So I'd work out the answer to that one. 4 multiplied by 7 take away 1. Work out the answer to that one. And then I would say, are those 2 answers the same or are they different? I hope I've explained that well enough. Okay, right, we'll go for it and then I'll go through the questions and then I'll go back and give you what I would say if they're the same or different. So we've got, oh, look, I've put BIDMAS down the side here very helpfully. Look, I was so organized when I was doing this slide. If only I had that brain on earlier in my slideshow production. I've actually changed my mind. I'm going to go through these as we go. Otherwise, there's going to be a lot of waiting around whilst I write things on whiteboards. Okay, so this one, let's have a little look. This one, the first one, we've got brackets, so we need to do those first. 7 take away 1 gives us 6. So we're going to end up doing 4 multiplied by 6, which gives us 24. The second one, we've not got the big bully brackets. We've just got a multiply and a subtract. Actually, that's unfair to say it's a bully. Just because it's more important doesn't mean it's a bully. So we're going to do the multiply first. 4 times 7 gives us 28. And then we take away 1, which gives us 27. So in this case, they were different. So the 2 answers in this case were different. What about this one? The same or different? Same or different? Will it take off as a quiz show? Probably not. Have I given you enough time there? So it's a little bit easier on Facebook because I get to see. Oh dear. Just give me a sec because my thing's trying to end the stream. I accidentally pressed something that I didn't mean to. Okay, same or different. So we've got 3 times 8. We're going to do 3 times 8 before the add. So 3 times 8 gives me 24 plus 2. That gives me 26. And then the second one, I've got to do, again, the multiply comes first. It doesn't matter about left to right. It matters that the multiply is done first. So that gives me 24. And then I do 2 plus 24, which gives me the same answer. So it's the same for that one. Okay, next one. Oh, did I? Oh, man. The whole stream thing has messed up my PowerPoint again. Here we go. Here we go. We're on a roll. We're not on a roll, but, you know, we're getting there. What about this? Same or different? Same or different? What do you reckon? I'm going to plug my laptop in because that could be interesting if the battery on that goes, Okay, this one's an interesting one. This one is an interesting one. Well, it is to me anyway, because multiplication and division are like the same level of importance, mathematically speaking. And that's because they're inverse to each other. If you do divide and multiply, like if you do 10 divided by 7, you get 70. 70 divided by 10, you get back to 7. Like you can inverse it using the other operation. So let's see how that impacts this. What order do we do it in? That is the question. Does it matter? Let's try with the first one. We'll do the multiply first. We'll do 4 times 10 gives us 40, and then divide by 2, which ends up giving us the answer 20. So I just went from left to right there. Let's do it the other way around here. Let's do the division first. 4 divided by 2 gives us 10, and then times that by 10. No, 4 divided by 2 gives us 2, not 10. I was skipping ahead there, wasn't I? Times that by 10. That gives us 20 as well. So interestingly enough, if it's multiplication and division, it doesn't matter what order you do it in, you're going to get the same answer because they're at the same equivalence of importance to each other. Okay, then I've got this one. Let's have a look. Same or different? So that one was the same. That one was the same. What about this one? We've got some brackets and some indices. What do you reckon here? Same or different? Are you going to get the same answer or a different answer? Is it the same? Is it different? It's definitely a valuable use of my time to come up with theme tunes for a hypothetical game show here. Definitely. I will not waste a Friday by doing that. Can you waste time? Let's not get into that right now. Okay. So we've got the brackets come first. Brackets are the boss. So we definitely need to do those first. 10 divided by 2 gives us 5. And then we're going to square that. 5 squared means 5 multiplied by itself. We're creating a 5 by 5 square. So that gives us the answer 25. We don't have any brackets in the next one, so we can go straight into doing the indice, which is the squaring. 2 squared means 2 times 2. That gives us 4. And then we're doing 10 divided by 4, which you may know, if I'm dividing by 4, I know it's the same as like dividing by 2 twice, so I half it and half it again. That's what I do in my head. I go 10, half it gives me 5. Half of that gives me 2.5. So in this case, it was different. In fact, very different, hey? Quite a big difference. It's like 10 times less. So that one was, yeah, totally different. And the last one, I know, you're not going to want it to be over, but this is the last one. This is the last one I can offer you today. Is it the same or is it different? Is it the same? Is it different? That's a bit jazzier, isn't it? I think I like that one better. Okay, let's have a look at this one then. Last one. So with this one, we've got the addition of brackets in the second one, haven't we? So we'll look at the first one. Indices is going to come first. So we need to do 7 squared, which is 7 times 7. That's going to give me 49. Then I need to do my multiplication. 9 times 2 gives me 18. I'm taking that off the 49. And then finally, I'll need to add 3. I can just do this left to right, subtraction and addition. 49, take away 18, that's going to give me 31. Plus the 3 is going to give me 34. Now, if I come down to this second one, I've got this addition of brackets, which means I need to do the brackets first. So those are going to give me 18. Then I can do my indices. 7 squared. 7 times 7 is 49. And I'm going to take away the 89 from the 18 from the 49 and then add the 3. So interestingly, even though we've got brackets in, it's given us exactly the same calculation. It changed the order of the operations, but because the brackets and the indices didn't interact with each other, gave us exactly the same amount. So this one was the same. Okay, so I need to, this is really important. I'm not live next week. I'm away camping and I don't trust the Wi-Fi. I looked into it and yeah, can't do it live. So what I've done for you guys, I've created a murder mystery. It was going to be a quiz. My brain took over in its less logical side and went for a murder mystery. It's awesome. It's a murder mystery with puzzles, as you'd expect. So what I'm going to do, I'm still slightly undecided if I'm going to record it and put it on YouTube for you, or if I'm going to just make it so you can download the PowerPoint. I'm going to decide before tomorrow because I need to load it up tomorrow because my husband's going to make me pack. So I'm going to make that decision and it'll be available for you to use whenever you want next week. Okay, so it'll be available from some point tomorrow. I'm going to say, yeah, some point tomorrow. So you can use it whenever you want next week. These lessons are free. We home educate, and I've been teaching for 15 years. I was a head of maths, and I wanted to use my maths knowledge and my knowledge about qualifications to help my home ed community. I do rely on people supporting me for an income. So if you can and you want to, you can pay £5 a week to become a triangle, and then you'll get my Math Mob memo. I'm working on the next one, which is on weather, to come out soon. Currently, there's this one here, which is all about fractals. So it's loads of hands-on activities, puzzles, quizzes, engineering tasks about fractals, which is a really cool, fun area of math that you never see in school, which is super annoying, with some origami paper and some funky stickers. You get that through the post. If you become a square, you also get workbooks that you can download so you can follow along in the lesson if you want to, but there's also like extra bits to do at home. Oh, I didn't say the bit of, if you wanted to say hi on YouTube. If you want to say hi on Facebook, please do. And I'll say hi back. You can go over there now if you're quick, maybe, and do that. But yeah, it's got the section where you've only got time to do 3 questions, problem solving, and I do video solutions for those so that you can find them and go through them, and then exam questions to practice, all linked to with the answers as well in those. Not many people aren't keen on saying hi on this one, but I'll check just in case because I don't want to miss people out if you have said hi. So yeah, don't worry if it's not for you, it's not a problem. But you know, if you have said hi, I do want to make sure I've said hi to you because you're very important and valuable to me. Let's have a look. Oh, no highs today. But hi to those that have been here. I've very much enjoyed having you here. I won't be live next week, but in 2 weeks' time, I will be back live. And if you want to join me for Maths in Art at 11:30, I will be live here doing that for you too. Okay. See you soon, guys. Thank you for joining. Bye for now. That's what I always say, isn't it? Bye for now. Just leave it open though. I need the breeze coming through.
Is it a bit? Do you want me to get that?